You mentioned early on, like size, it's hard to grow. What did you mean by that? Because we're talking about scale might change. Uh, there might be, and we'll talk about this too. Like there's a emergent. There's certain things about these neural networks that are emergent. So certain like performance we can see only with scale, and there's some kind of threshold of scale. So why is it hard to grow something like this meow network?
So the meow network is not, it's not hard to grow if you retrain it.
Yeah.
What's hard is, well, we have now 1 billion parameters. We trained them for a while. We spent some amount of work towards building these weights that are an amazing initial brain for doing this kind of task we care about. Could we reuse the weights and expand to a larger brain? And that is extraordinarily hard, but also exciting from a research perspective and a practical perspective point of view, right? So there's this notion of modularity in software engineering, and we're starting to see some examples and work that leverages modularity. In fact, if we go back one step from Gato to a work that I would say trained much larger, much more capable network called Flamingo. Flamingo did not deal with actions, but it definitely dealt with images in an interesting way, kind of akin to what Gato did, but slightly different technique for tokenizing. But we don't need to go into that detail. But what Flamingo also did, which Gato didn't do, and that just happens because these projects, they're different. It's a bit of like the exploratory nature of research, which is great.
The research behind these projects is also modular.
Yes, exactly. And it has to be, right? We need to have creativity, and sometimes you need to protect pockets of, people, researchers, and so on.
By we, you mean humans?
Yes.
Okay.
And also in particular researchers, and maybe even further, DeepMind or other such labs.
And then the neural networks themselves. So it's modularity all the way down. Okay.
All the way down. So the way that we did modularity very beautifully in Flamingo is we took Chinchilla, which is a language-only model, not an agent if we think of actions being necessary for agency. So we took Chinchilla, we took the weights of Chinchilla, and then we froze them. We said, these don't change. We trained them to be very good at predicting the next word. It's a very good language model, state of the art at the time you release it, etc., etc. We're going to add a capability to see, right? We are going to add the ability to see to this language model. So we're going to attach small pieces of neural networks at the right places in the model. It's almost like injecting the network with some weights and some substructures in the ways, in a good way, right? So you need the research to say what is effective, how do you add this capability without destroying others, etc. So we created a small subnetwork initialized not from random, but actually from self-supervised learning, that a model that understands vision in general. And then we took data sets that connect the two modalities, vision and language. And then we froze the main part, the largest portion of the network, which was Chinchilla, that is 70 billion parameters. And then we added a few more parameters on top, trained from scratch, and then some others that were pre-trained from with the capacity to see. Like it was not tokenization in the way I described for Gato, but it's a similar idea. And then we trained the whole system. Parts of it were frozen, parts of it were new. And all of a sudden, we developed Flamingo, which is an amazing model that is essentially, describing it is a chatbot where you can also upload images and start conversing about images, but it's also kind of a dialogue style chatbot.
So the input is images and text, and the output is text.
Exactly. And
how many parameters? You said 70 billion.
70 billion
for Chinchilla.
Yeah, Chinchilla is 70 billion, and then the ones we add on top, which kind of almost like a way to overwrite its little activations, so that when it sees vision, it does kind of a correct computation of what it's seeing, mapping it back to words, so to speak. That adds an extra 10 billion parameters. Wow. Right? So it's total 80 billion, the largest one we released. And then you train it on a few data sets that contain vision and language. And once you interact with the model, you start seeing that you can upload an image and start sort of having a dialogue about the image, which is actually not something. It's very similar and akin to what we saw in language only. These prompting abilities that it has, you can teach it a new vision task, right? It does things beyond the capabilities that, in theory, the data sets provided in themselves, but because it leverages a lot of the language knowledge acquired from Chinchilla, it actually has this few-shot learning ability and these emerging abilities that we didn't even measure once we were developing the model. But once developed, then as you play with the interface, you can start seeing, wow, okay, yeah, it's cool. We can upload. I think one of the tweets talking about Twitter was this image from Obama that is placing a weight and someone is kind of weighting themselves and it's kind of a joke style image. And it's notable because I think Andrej Karpathy a few years ago said, no computer vision system can understand the subtlety of this joke in this image, all the things that go on. And so what we try to do, and it's very anecdotally, I mean, this is not a proof that we solved this issue, but it just shows that you can upload now this image and start conversing with the model, trying to make out if it gets that there's a joke because the person weighting themselves doesn't see that someone behind is making the weight higher and so on and so forth. So it's a fascinating capability. And it comes from this key idea of modularity, where we took a frozen brain and we just added a new capability. So the question is, should we? So in a way, you can see even from DeepMind, we have Flamingo that this modular approach, and thus could leverage the scale a bit more reasonably because we didn't need to retrain a system from scratch. And on the other hand, we had Gato, which used the same data sets, but then it trained it from scratch, right? And so I guess big question for the community is, should we train from scratch or should we embrace modularity? And this goes back to modularity as a way to grow, but reuse seems like natural, and it was very effective, certainly.
The next question is, if you go the way of modularity, is there a systematic way of freezing weights and joining different modalities across, not just 2 or 3 or 4 networks, but hundreds of networks from all different kinds of places? Maybe open source network that looks at weather patterns and you shove that in somehow. And then you have networks that, do all kinds of stuff, play StarCraft and play all the other video games. And you can keep adding them in without significant effort. Like that, maybe the effort scales linearly or something like that, as opposed to like the more network you add, the more you have to worry about the instabilities created.
Yeah, so that vision is beautiful. I think there's still the question about within single modalities, like Chinchilla was reused, but now if we train a next iteration of language models, are we going to use Chinchilla or not?
Yeah, how do you swap out Chinchilla?
Right. So there's still big questions, but that idea is actually really akin to software engineering, which we're not re-implementing, libraries from scratch. We're reusing and then building ever more amazing things, including neural networks with software that we're reusing. So I think this idea of modularity, I like it. I think it's here to stay. And that's also why I mentioned it's just the beginning, not the end.